So we're going to have, let's randomize these durations just for the fun of it. Let's have a new object up here, random 3, let's say. We'll have 3 different durations. We don't want any 0 durations, so we'll have +1 on there. And we're going to have a durations multiplied by 500. So it'll be, you'll have durations 500, 1,000, and 1,500. Yay. So we're going to trigger that random time and use that as a time interval, so it sounds like, well, only a tiny bit more interesting maybe, but anyway. Still sounds like pretty much a knucklehead percussionist. Alright, I'm not saying anything particular about percussionists. Alright, what I'm going to do here now is I'm going to put a delay in here, and we're going to use the tap in and tap out that we've used before. So I'm going to make a new object with a tap in tilde, and tap in always wants to have some kind of argument which is going to be its maximum delay time. So in this delay line I'm not going to get more than 1 second of delay, which is quite enough for what I want to talk about. Alright, and every tap in, every good tap in deserves a tap out, so another new object, tap out. We can put an argument in there, 1,000. I'm going to change that delay time, but well, for the moment we'll just put it in there so we can hear how wonderful this thing is. I'm going to disconnect the outlet of this multiply from the right inlet of my DAC, and I'm going to put that. I'm going to have the delay come into the right channel here, so we can hear what this sounds like. Okay, that's very good. That's a bit like like any number of rounds, and so this guy is like singing everything this guy's singing 1 second after he sings it. I'm going to modulate that delay time, so for that I'm going to use a new object, line tilde. We'll take the tilde flavor, and we're going to hook that up to there, and every time I play a note I'm going to change my delay time. So I'm going to make a message here, a message with, let's say, 1,000, comma, 0 over 1,000. And what this message will mean to a line tilde is that it starts at 1,000, and then this 1,000 comes out by itself because of the comma. So we start at 1,000, then we go to 0 over the time of 1,000. So start at 1,000, go to 0 over 1,000 milliseconds. I'll hook that up to, let's say, the outlet of that float box there, so that every time I get a note, it's going to start the delay line at 1,000, and it's going to go to 0 over 1,000. It should be like this. Okay, and that's doing the same notes, or it's using the same notes coming out of here, but they're up an octave. And why is that? Well, you think about it. With the delay line set at 1,000, we had no change of pitch, which is what you'd expect. It's just sitting there. But then when you read back through the delay line, going towards its origin, or its 0 delay, over 1,000, that's essentially speeding up the sample, the sampling, or looking at the samples, it's speeding it up by twice. So I mean, there is, if you look on Wikipedia or whatever, look up Doppler, and in this case you're looking at something where the observer is moving, like the delay line is basically our observer. The source is stationary, our vibraphone's not going anywhere. And you can imagine this, we'll just call V, this is the F, the sound, the frequency you hear, and this is the frequency of the source. You can imagine V could be considered to be 1, let's say, because Why? Because 1 is the sampling rate. Well, it's actually not 1, but who cares? But let's say in this case we're reading through the delay line. We're going towards the source at the speed of the sampling rate. So it's like this would be 1 plus 1 over 1, which is 2. So 2 times the original frequency is the way it's going to sound. If we use something that's slower than, let me just do it over here. If we do something that's slower, i.e. we start at the start of the delay line and go towards the end of the delay line. Let's say we're going to the end of the delay over 2000. We should be now, according to this, well, let's hear it first. Okay, now this time we're going, this value here, VR, is actually 0.5 because we're going through, is it? No, it's negative 0.5. We're starting at the 0, so we're going slower than 1 because 1 is not moving anywhere at all. We're going slower, and we're going slower by 0.5, so it's negative 0.5. That's the way I'm going to call it, like this anyway. So 1 plus negative 0.5 over 1 would be half, or 0.5, so yeah, that would be half the frequency. Alright, and it might seem obvious to you already, but if I change this second value in here, so we're going to 1000 over 1000, we're essentially going to hear no frequency while this thing's moving, while the delay line's changing, while the delay is changing. Because, why? Because we're essentially reading out staying on one single sample, because the sound we're reading through the delay line at the sample rate at the same time as we're putting things into it, so it's going to be sitting there stationary for the most part. Well, yeah. You can hear the delay, the 1 second delay still, but not, but you're not hearing it while it's ramping. We can actually make this thing, if we go faster, even if we read through the delay line even faster than sitting still, so that we're now, let's say according to this thing, we could say this is now negative 2, so we're going through the delay line twice as fast in reverse. So 1 plus negative 2 over 1 is, what's that? Oh my goodness, maybe that's, is that even right? Probably not. With this going, we had negative 1, which was making it stand still. 1 plus negative 1 is 0 over 1. That would make sense. 1 plus, let's maybe just throw this away. Essentially what we're going to be doing is reading through this delay line so fast that we're catching up to the samples and surpassing the ones that are coming in, so we actually end up with something that does this. So every time it's doing this modulation here, it's actually reading through the samples backwards, or it's reading through the order of samples backwards anyway. Yeah, that's probably about enough. If you're a mathematician and you want to try and help me out with this thing, then please, leave a comment. It's all gravy. And until tutorial 15, that's about enough from me. Thanks. Cheers.